In this video, we're going to look at error detection within data transmission in computer science. So another keyword. So in the last video, we spoke about bandwidth. Now, bit rate is similar to bandwidth in that it measures the amount of data transferred in a fixed time frame. However, bandwidth is the theoretical capacity. So for example, I pay for 50 megabits of broadband, but I don't always get that. So that's how much I pay for, that's how much I should get, but that's not always the case. The actual bit rate is the actual rate at which a message is being transmitted, which it can vary. It can be if you're downloading something from America and you're all the way in Vietnam, it's not necessarily going to be as quick as you downloading something from England and living in England. Okay, so another way to see bit rate is how much of your bandwidth as an application is actually using for their communication, because not every application is going to use all of your bandwidth, because otherwise you won't be able to do anything. And it's also measured in bits per second. So error checking. It's really important in data transmission that we're checking for errors, because we're sending lots of data. It could be something really sensitive, it could be something really important. It might not, but it might just something that needs to be accurate. But if data becomes corrupt, you don't get that data, so suddenly the whole point of you sending the data is for somebody else to receive it. If it's corrupt, it's not going to work. One thing that's more annoying is, like, say you get an old video camera out, put the SD card in and go, I'm going to see some pictures from years ago, and you can't because the data is corrupt. You know, that's a right pain. Imagine you sending some really important files, or I don't know, sending an email that had loads of important documents and they got corrupt somehow. You'd be really, really mad, you'd be really annoyed that you've put all this effort in and it's not worked. Okay, so we need to error check. So one way of doing error detection is using Parity Bits. So we use a Parity Check to make sure the data has been sent accurately. So data is sent with 7 bits diverted to the actual data and 1 bit diverted to the parity. So there's 2 schemes of Parity Check. You've got the odd parity and you've got even parity. So in even parity, there must be an even number of ones, and in odd parity, there must be an odd number of ones. And we use the parity bit to ensure the data matches the even or odd parity before we send. So let's imagine that I'm transmitting this data using even parity. So we take a look and we count the ones. We've got 1, 2, 3, 4, 5. So we need to put a 1 in there because we've got 5 ones and there should be either 4 or 6. So I can put a 1 in there. Okay? So like that. So if there's an error in transmission, it's easily detected because we suddenly count again. We've got 1, 2, 3, 4, 5 ones, because this 1 has turned to a 0, so there's been a mistake there, there's been an error. However, some issues with parity is that we transmit the data using non-parity, so we've got 1, 2, 3, 4, 5 ones. An error occurs, but it's not detected, and that's because these two are swapped around, so there's still the same number of ones, but the data's in the wrong order, so it's actually incorrect. So despite the error, the data's still got the same parity, so that's an issue. Another issue is we can't actually tell where the error is, so we just need to ask for the data again, which we'll talk about later, which, if you have got a problem, the best thing to do is just ask for it again. You know, if I make a mistake on something, it's a lot easier for someone to say, oh, that's not right, can you do it again, than trying to correct little errors and things like that. So we've got an example here. So you might be asked to complete a data packet by adding the correct bit. So these are odd parity. So the first one, we've got 2 ones, so we need to add an extra 1 to make it 3 to make it odd. This one, we've got 3 ones, so we can add a 0. And next one, we've got 1, 2, 3, 4, 5, so we can add a 0. So those parity bits are now complete. Now, the following packets were sent with an odd parity. Determine whether there is an error in the data. So So again, it's odd. So we've got 1, 2, 3, 4, 5. So there's not an error there. And then we've got 1, 2, 3, 4. So there is an error somewhere there. So no and yes. Now, the major flaw with Parity Bits was that we can't tell where an error has occurred. Now, the main reason for this is that it's one-dimensional. There's no way to determine where an error actually happened. So the best solution is to do it in data blocks and add a second dimension, so you've got an X and a Y. And this is done by using Parity Byte transmission. So we take a look at this. This is the Parity block. So we've got all the bytes and we've got the bits. Now, we're using even parity, so each row and each column, so these added up and these added up must be even. So you can see we've got 1, 2, 3, 4, 5, 6 there, and here we've got 1, 2, 3, 4, 5, 6 there, so it's even. So this column in bit 5, 1, 2, 3, 4, 5 bits instead of 6, or instead of 4. And then this row, we've got 1, 2, 3. So we highlight that row, we highlight this column, and you can see where the error is. So the actual mistake is in this part here. That's where the error is, and we can fix that. So let's take a look at an example question. So we've been given the parity block, and we've got to figure out if there's an error. So first things first, they'll either give you the answer in terms of whether it's odd or even parity. Sometimes, like in this question, they haven't. So first thing to find out is it odd or even parity? So we look. So we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. So most of them are 5 or 3, which means it's an odd parity. So we look at the first row. So we've got 1, 2, 3, and we've got 1, 2, 3, 4, 5, 6, 7, and we've got 1, 2, 3, 1, 2, 3, 4. So I'm already thinking at this point that this byte here has got some form of error on it. So we already know it's byte 4, this row. Then we take a look at the bits and go down, because both the bytes and the bits need to line up. So we've got 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4 again. So I'm thinking bit 6, so I'm thinking we look right at cross sections and the error is there. Okay, now I apologise for that being quite messy, but that's how you find out your error. Now to deal with an error, we need to think about what we can do to actually solve these, the problem of getting errors. It's great if you can detect them, but what do we actually do? So data is actually sent over the internet as packets, which I'll cover in a later video. Now the easiest method of dealing with an error is by using an automatic repeat request on ARQ. Essentially, whenever there's a packet missing or something that's like corrupt or gone wrong, we just send a request to the computer that sent it or device that sent it and ask to resend the data until it's successful, or until we've reached a limit. So it might be 30. So it sends it 30 times, it's wrong every time, then we go, you know what, it's wrong every time, you give up on it, and we'd solve something else. And that's it really. So hopefully that was helpful and you understand about error detection using Parity Bits, Parity blocks and automatic repeat requests. And I'll see you in the next video.